Hi my dear student, today we will discuss chapter 3 Trigonometry. Exercise 3.4 question number 17. Prove that sin of a plus b into sin of a minus b which is equal to sin square a minus sin square b. Got it? So my left hand side sin of a plus b into sin of a minus b. Sin of a plus b formula sin a cos b plus cos a sin b. This is sin a minus b. Using sin a minus b formula, sin a cos b minus cos a sin b. So I will use respectively compound angle sin a plus b and sin a minus b. Sin a plus b, sin a cos b plus cos a sin b. For sin a minus b, sin a cos b minus cos a sin b. When you read this two, this is a plus b into a minus b. See, both are same and these two are same, in between plus and minus. So this is a plus b and this is a minus b. What is a plus b into a minus b? A square minus b square. Got it? Very simple. This is in the form of a plus b into a minus b, which is nothing but a square minus b square. A square sin square a cos square b minus b square cos square a sin square b. See the proof. I have sin square a minus sin square b. I need everything in terms of sin. So I'll keep this sin square a as it is. I'll write this cos square b as 1 minus sin square b because I need everything in terms of sin. And I'll write this cos square a as 1 minus sin square a. Okay. I can write cos square b as 1 minus sin square b and I can write cos square a as 1 minus sin square a. Now multiply. Sin square a into 1 sin square a minus sin square a into sin square b. Now take this minus sin square b inside. Minus sin square b. Minus into minus plus sin square a sin square b. These two get cancelled. What is left? Sin square a minus sin square b. See, this is what your right hand side. Sin square a minus sin square b. Hence, prove. Very simple. When you see the question, you want to prove that sin a plus b into sin a minus b, which is equal to sin square a minus sin square b. Basically, in the left hand side, sin of a plus b and sin of a minus b. I'll use compound angle formula. When you see this line, this is the form of a plus b into a minus b. That is a square minus b square. So a is nothing but sin a cos b and b is nothing but cos a sin b. Therefore, sin square a cos square b minus cos square a sin square b. This is the standard step. See the proof. I have sin square a minus sin square b. I need everything in terms of sin. So according to that, I will change my cos square b as 1 minus sin square b, cos square a as 1 minus sin square a. Suppose if I need in terms of cosine, I will keep my cos square a and cos square b as it is. I will replace my sin square a as 1 minus cos square a and I will replace my sin square b as 1 minus cos square b. Suppose if I need in terms of cosine everything. In this case, I need in terms of sin, so that I am going to keep my sin square a and sin square b as it is. I will change my cos square b as 1 minus sin square b and cos square a as 1 minus sin square a. And then I am multiplying. These two get cancelled, both are same. Minus sin square a sin square b. Here plus sin square a into sin square b. What is left? Sin square a minus sin square b. That is what your right hand side. Hence proved. Got it?